Greetings, class. I have another video for you. I figured I'd give you a break from using Excel in this video. Chapter 3 goes over the topic of weighted mean. This is also called weighted average. You got to be careful. In statistics, average could mean mean or median or even mode. There is something called a weighted median. We're not going to do that. But in business and everywhere else, when they say weighted average, they mean weighted mean. So that's what we're going to talk about today. By the way, weighted mean is a math topic that is taught in middle school in Texas, in the 7th grade if you're in on-level math, in the 6th grade if you're in advanced math. And so most Americans cannot calculate a weighted average, even though they have high school diplomas or college degrees. Some people with PhDs can't calculate a weighted average. That's a terrible shame. Anyway, we're going to calculate a few right now. What is a weighted average? Well, a weighted mean is an average that gives different weights to the data used to calculate the mean. The best way to show this is to do some examples. But before we do, we're going to have to use decimal versions of percentages. As you know, you can express a percentage either with a number with a percent sign after it or the decimal format. When we calculate a weighted mean, we must use the decimal format. The other thing won't work. So let's just review. Again, this is a review. This goes back to middle school. If you have the number 10% and you want to express it in the decimal format, what do you have? 0.10. That's 1/10, right? 0.10. If you have a decimal percent of 0.50 and you want to express it as a percent with a number with a percent on the end, what is it? That's half. 0.50 is half. That's 50%. Half of something is 50%. By the way, these are just a few examples, right? 5% in the decimal form is what? 0.05, not 0.5. Oh, nobody would put 0.5 to mean 5%. Nobody in the entire world. Not that in the past any of my students have ever done that. Of course not. 0.05 is 5%. 1/20th. 1/20th is 5% of something, a small amount. If you have a decimal of 0.01, that's 1%. 1/100th is 1% of a dollar, for example. Now, what about this 2.5%? That's a little tricky, but you know, these things come up all the time in business, especially interest rates. They're often not whole percentages, are they? In fact, you could even have 2.59% or something like that. So what is 2.5%? Is it this? 0.25, is that right? No, 0.25 is a quarter of something. That's 25%. You got to put a 0 in here, right? Now I threw in one down here, 0.8. Is that 8%? No, that's 8/10 of something, which is a ton of something. That's 80%. And now look at this one, 0.5%. Is this 50%? 0.5%? Is this half of something? No, 50% is this. This is a tiny little percent. What is this? It's less than 1%. It's 1/2 of 1%. 1/2 of 1%. So how do we show that over here? Like this? No. That's 50%. Like this? No. That's 5%. Like this. That's 1/2 of 1%. Okay? So it's good to be able to do this stuff. When we do weighted average, we have to sometimes convert this number to its decimal form. If you make a mistake doing that, your answer will be wrong. In fact, it might be ridiculously wrong. Remember, an average is something in between. It's a measure of the middle, something in between. Let's do an example here. Of course, most courses in college, the different types of coursework have different weights. Let's start with a less complicated one. You know, it used to be more common, like back when I was in college, back, in the Stone Age. In some of my classes, we would only have two things that were graded, a midterm and a final exam. We might have homeworks, but they weren't graded. People would do them anyway. Try that now. When I give homeworks that aren't graded, nobody does them. The whole point of the homework was to practice for the tests because the test questions are similar. I can tell it to students today. Somehow they still don't do it. It's not common today to have only two things graded in a course. Certainly not true for our course. So here's Biff. He took a course. All it has is a midterm and a final. The midterm counts for 40% of his grade. The final exam counts for 60%. What is his semester average? It's not 90. If you didn't bother with the weights, if you did a regular old average, what would you do? Not this. You would add up the two numbers and divide by 2. That's not it. Wrong. Unfortunately for Biff, the final is supposed to count more than the midterm. That means his average will be closer to the final score than it will be to the midterm score because the final has a bigger weight. So how can we calculate the weighted average? Well, you have to convert, let's note, right here, math note. 40%, what's the decimal form of 40%? No, my software did that. My software is getting ahead of me. The decimal form of 40% is what? 0.40, right? The decimal form of 60% is, no software getting ahead of me, 0.60. So, how do we calculate the semester average? Here is Biff's. Now, the book shows you a formula with like letters in it. And if you can't read formulas, you might as well be reading a foreign language, Japanese or Russian or something. And most students can't read algebraic formulas. I'm not even going to bother with the formula with the letters in it. We're just going to do it. How do we do it? Okay. The midterm counts 40%, right? So what do we do? Here, in fact, I'll make like the midterm things, what, purple? That's kind of hideous, man. Here, that's a little better. Right? 40% goes with 100. Because that's the weight. Yes? 60%, I'll make it a different color. Not this. This is a lousy. How about red? 60%, that's the weight of this. Yes? Yes. So how do we calculate this? Here, do a parentheses. I'm going to start with the midterm. You take the weight of the midterm and you multiply the midterm grade. That's the first thing. That's the purple. That's the purple. That's the purple. Then we got to put the final in there. You take the weight of the final, 0.60, multiply it by the grade of the final. That's the red. And we'll get some number between 80 and 100. An average is always between the two numbers. But it should be closer to 80 than it is to 100 because the 80 is given a bigger weight. Now I hope my software comes through and calculates this. Yes, 88. Biff's semester average is 88. If the professor doesn't curve, poor Biff is going to get a B. Or at most schools you'd get a B+. We don't have pluses at Prairie View or minuses. So that's the answer. Each item that's being used to calculate the mean is given a weight. By the way, the weights have to add up to 1. If they don't add up to 1, you can't do a weighted average. Well, there's a really weird average, but that's not beyond the scope of our course. The weights have to add up to 1. You see how 0.60 plus 0.40 add up to 1. If the weights don't add up to 1, you can't calculate. When calculating a weighted average, the weights must add up to 1. They have to. Just like in this example, right? .40 plus 0.60 equals 1. So this is about the least complicated weighted average you can do. Two numbers. You can't average one number. Slightly different weights, not hugely different. Let's try a couple more examples. Now, in our course, I copied this from the syllabus. That's why it's a different font. There are 5 things, 5 types of things that are in the semester average. This is more typical now these days. They have different weights, right? We need to convert each of these to decimal version. Math note. 15% equals what? Decimal version. By the way, if you're not good at this, I don't know who to blame. I'm not going to blame you in the past, but you now can fix that. You now, college graduate, can fix your math shortcomings by practicing. If you don't practice, you'll never fix them. And now, then I can blame you, right? Then I can say, look, I don't know what happened when you were a kid. I have no idea, but now you're an adult. Recognize your shortcomings. Fix them. So we know that, 15%. Now we have two 15%. I don't have to put them in twice here. 20% is what? 0.20. I'll put them a little farther apart. And we're going to use so we're going to use 0.15 when we calculate this thing. We're going to use it twice, here and here, right? 0.20, we're going to use it twice, here and here. And then we're going to use 30% or 0.30 once. 0.30. Okay, so here's the calculation. See, imagine this is your professor at the end of the semester calculating the weighted average. Practice set average, 90. That's worth 15%. So what do we have? Parentheses, 0.15 times 90. That takes care of the practice sets. What about online discussion posts? That's 15%. Her score was 91. So, 0.15 times 91. We've taken care of 2 out of the 5. We got 3 left. The next one is exam 1. That's worth 20%, 0.20. And her score on exam 1 was an 89. 89. That took care of exam 1. Now, exam 2 is also worth 20%. And what did she get in exam 2? 95. All right. Come back. Then, final exam, worth 30%. That's a big one. Uh-oh, she only got an 80 on that one. Oh well, 0.30 times 80. Let's see what we get. 87.95. If there's no curve, that's a B at Prairie View. It would be a B plus in every other school. The only other college I ever taught at that didn't have pluses and minuses was Houston Community College. They didn't have pluses and minuses. Every other college has pluses and minuses. That's how it's done. Weighted average. I got one more example, because these are from grading. What about business? Well, I'm an economist. I happen to be teaching statistics. When you take if you're in a PhD program in economics, you have a lot of statistics, because statistics is used quite a bit in economics, just like in business. Oh, let me go back. Look, the weights add up to 1. And when you add these all up, if they didn't, something would be wrong. They have to add up to 1. Let's do it. 0.15. You got to add them all. Now we used 0.15 twice, so you got to add it twice. And we used 0.20 twice. Oh, come on. You're going out of my screen. Can you see that? Here, let me move this up. I'm not sure. I can't quite tell for sure where the bottom of the video is going. So look, 0.15. That's this one. Then another 0.15. That's this one. Now we got to do 2 0.20s. 0.20. And another one. 0.20. And then we used 0.30. Equals 1. The weights must add up to 1. And they do. Now let's look at an example from economics. When our government calculates inflation rate, they give different weights to items that are bought. The more money you spend on an item, the bigger the weight it has. And this makes sense. Like housing is a big expenditure for the average consumer. When they calculate inflation, they give that a huge weight. Things that you don't spend a lot of money on, like lemons, at the store, would have a tiny little weight. Who cares if the price of lemons doubles? You don't have to buy them. If the price of your rent doubles, you're screwed, man. You're just totally screwed, aren't you? So, I'm pretending now. Now, in the United States, when they calculate inflation, they have 10,000 items. I'm pretending this fake country, there's only 5. It'll fit on the page now. We could do the exact same thing with 10,000 items. Give everything a weight and calculate the weighted average, but it wouldn't fit on the page. So I have only 5 things: food, housing, medical care, transportation, everything else. And this is the percent of the consumer budget spent on each item. So there's nothing else they spend money on. It's just these 5 things. That means if you add these up, you should get 100%, if I did it right. Let's see, 25 plus 35 is 60, plus 12 is 72, plus 10 is 82, plus 18 is 100. So that's 100% of the budget is divided between these 5 things. Housing is the biggest one. This is going to get a weight of 0.35 in the inflation measure. This is how much the price of each product has gone up over the past 12 months. Housing has gone up a lot. Meanwhile, something has gone down. So we can calculate a weighted average of these numbers, and that's what an inflation rate is. An inflation rate is a weighted average of price increases of things that consumers buy, where the things consumers spend a lot of money on are given a bigger weight than the things consumers spend less money on. So let's calculate this weighted average. Now we have 2 columns of percentages. This might be a little confusing. These are the weights. Remember, the weights have to add up to 1, or in this case 100%. These are the numbers that we're averaging. An inflation rate is what they call an increase in the average price level. We're averaging these using these weights. So let's do it. So the food weight, I'm going to start with food. 25% is 0.25 times 6%. Now we can just put a 6 in here. If we remember to add a percent at the end, we can use these numbers. We got to remember to put a percent sign on whatever we get at the end. If we don't remember that, we're screwed. So this 0.25 times 6, that takes care of the food. Now we got to do housing. That's a big one. 0.35, and that went up 11%. We'll put the 11 in here. Okay. Now we go to medical care. 12% is the weight, 0.12, and it went up by 4%. Now we're at the transportation. 10% is the weight, 0.10, and it went up by 2%, and everything else, 18%, 0.18, it went down times -1. You're allowed to do that. It's perfectly fine. Nothing wrong with that. And what will my software get? 5.85. And this is where you have to remember to put the percent sign. We've been leaving it off here because my software doesn't like it if I put a percent sign on here. But we got to remember to put it back here at the end. That's the inflation rate. You see how it's between the lowest and the highest number? That's an average. An average is always between the lowest and the highest number. But it's closer to these, isn't it? Because these have the bigger weights. It's nowhere near the smaller ones. It's closer to the bigger ones. And so, let's just note that the weights add up to 1. Don't forget that. You see, having taught statistics since, I was a teaching assistant. I forget, 1992 in a statistics class. I know the mistakes that students make. You got to have weights that add up to 1. If you didn't do that, that's a way to think, wait a minute. I made a mistake. Let me go back and see what I did wrong, right? Let's add them all up. Right? Those are the 5 weights, and we get 1. So that's it. weighted average. Now you can calculate your own semester average. You don't have to bother me. I don't mind. You can ask me. But that's it. You take the numbers that you use to calculate the average and you multiply each one by its weight, making sure that the weights of all the items add up to 1. You have to have a weight for every item you're averaging. If you have 10 things you're averaging, you need 10 weights. If you have 9 things you're averaging, you need 9 weights. If you have 2 things you're averaging, you need 2 weights. That's pretty much it. That's the end of the video. I hope you enjoyed it. Next time we're on to Chapter 4. Till then, Professor Williams is saying, have a good day.